Hello everyone, I am Professor Vaibhav Shah. Welcome to yet another lecture on engineering curves. In today's lecture, we are going to learn involute of a square. Practically, there are many types of involutes possible, like involute of a circle, involute of a pentagon, involute of a hexagon, and so on. In subsequent lectures, we'll be learning each of these types one by one. If you like my content and teaching style, then do not forget to like and subscribe to show your love and support. And try to share it with your friends, which might help them to clear their concepts. Let us start with one of the problems. Problem 1. A string is unwound from a square of 25 mm side. Draw the locus of point P of string for unwinding the strings 1 turn. The string is kept tight during unwinding operation. Draw tangent and normal to the curve at any point. So here, let us analyze the question first. A string is unwound from a square. That means we are dealing with unwinding of a string first. Secondly, we are unwinding the string from a square. So unlike our previous examples, we are dealing with our object as a square. So we'll replace the circle with the square in this case. And the square dimension is given of 25 mm side. Another thing is you have to draw the locus of endpoint P of the string. So now, whenever you look for these lines, draw the locus of endpoint of string. That means you have to simply draw the involute of any object whichever is given to you. Now, lastly, we have to draw tangent and normal to the curve at any point. So you can select point anywhere on the curve, and at that point you have to just draw tangent and normal. So now, let us understand and take few assumptions first. So here we are assuming that unwinding of the string, and second, length of string in this case would be the length of string equal to 4 into L. 4L is nothing but the perimeter of the square. So you will ask, sir, what do you mean by perimeter of the square? So let us see by this object. So if we start my journey from 0 point, and I just start journey on the square from 0 till 1, 1 to 2, 2 to 3, 3 to 4. So this surface, outer surface of square is nothing but known as the perimeter of your square. So which is L length, L, L and L. So it is 4 times L. So that's why we are taking the length of string winding or unwinding from the square must be equal to 4L, equal to the perimeter of your square. So now let us first calculate the required length of string. Now what is the required length of string? So required length of string means the string length which we require to complete the cover, completely cover the surface of the square. So we require obviously the circumferential length of the square, so which is nothing but the 4L. So 4 into L, length of the sides of the square. So here it is said that 25 mm side of the square. So that means the squares, each of the sides of the square would be of 25 mm. So we are just multiplying 4 into 25. So we'll be having 100 mm as our string length. So we might require the 100 mm length of string to just completely wound around the square. So now let us start the example. So first of all, we have to draw one square with 25 mm side as said in example. After that, let us give numbering to this square 0, 1, 2, 3 like this. Now let us attach one string at 0 point like this horizontally. So the length of the string would be of 100 mm. Now this is the case of your unwinding of the string. So we must focus on the numbering pattern on the square. So now how would I give the numbering pattern like this or any other pattern? So let us justify the logic of giving the numbering pattern to this square. So we are assuming that we have already wound the string around this square, and we need to open up this string, or we need to unwound this string like this. So let us suppose that our string is completely wound around the square. Now we are opening the string from your P0 point or 0 point on the square, and we try to open up string like this. So this is your now final string length, and this is the final point of your end point of your string. So what we have done is we have just opened the division from 1 till 0 of your string, and when we are opening this string, so this will be your final string, and the end point of the string would be now new point, which is P1 point. So as you can see, the string got opened around this first point. So string got open around this first point. So this is nothing but your point number 1, or you can write down this point as your point number 1. You can't specify this point as your point number 1, but you have to specify this point as a 1. Why? Because I have told you the logic. We are opening the string of 0, 1 length like this in anti-clockwise direction. So this would be the end point of your string now, and this is your complete string length. So we are opening the string around this point first. That's why we have defined this point as point number 1. Now this is point 0, this is point 1, then this would be, must be the point number 2, this is point 3, and this will be final point 4. So point 4 and point 0 would be the same point, which is a starting point and ending point of your string. After that, we must draw the tangent from each of the points. So let us draw one tangent line from one point. Extend this line from 1, you will be having tangent from 1. Extend this line from your point 2, you will be having tangent from your point 2. Extend the line from 3, you will be having tangent from 3. And extend the line from 4, you will be having tangent from 4. But as you can see, we have already drawn the line from your 0 and 4 points. So you need not to draw another line, because we have already drawn one line of 100 mm from your 0th point or 4th number point. After that, what? So very simple. You have to take out your rounder. You have to put your rounder at point number 1, and you have to take the radius is equal to 1 till 0, and you have to draw one arc. So you will be having this point cut on the tangent line of your 1. You will be having this point P1. Now next step, you have to put your rounder to the next center point, which is point number 2. You have to take the complete string length until your point P1, because this is the end point of your string now, P1. So you have to take on your rounder 2 till P1 distance, and 2 as a center, 2 P1 radius. You have to just simply draw one circular arc. It will cut your tangent line of 2 at this point P2. Then you will be having this point, final point, as P2. Now you have to just change the center. Now take the center as 3 point. Take the end point of your radius 3 till P2, because this will be now end point of your string. So this is your string or your thread. So this is your center. So 3 as a center, 3 P2 as a radius. Draw one arc. You will be having arc cut at the tangent line of 3 somewhere here. You will be having this P3 point. So once again, what we have done is we have taken 3 as a center, 3 P2 as a radius, and we have simply just drawn one arc. It will cut your tangent line of 3, and you will be having this P3 point. Now change the center to your final point 4. Take the radius on your rounder from point 4 till your P3 point, and try to draw one arc, circular arc, and it will cut this tangent line of 4 somewhere here, and you will be having point P4. So as you can see, while drawing your circular arc, you will curve already generated, which is automatic generation of the curve by simply drawing this circular arcs by your rounder. So you have final curve generated by your rounder. So name this curve as P0, P1, P2, P3, P4. Unlike our previous example, we need not to join this curve, because while drawing these arcs, we have already generated this curve, which is nothing but our required involute of a square. Now let us come to the last point. Draw the tangent and normal to the curve at any point. So let us select any point. So I have selected any point S on this curve. So this is my point S. So now simply you have to connect this point S with the center 3. Now you will ask, why sir I have connected this point to center 3? So always remember, you have to find out the center of this radius, because you are now currently standing or placing your point between your point P2 and P3. So you are on the curve P2, P3. So you have to find out the center of this curve. So it is obvious that we have generated this curve between your P2 and P3 by taking 3 as a center and 3 P2 as a radius. We have generated this curve. So we are currently standing on this S point, and S point is generated by your center 3. That's why we are connecting this S point to your 3 point. and you have to simply connect this line and you have to extend this line. This is nothing but your normal, and when you draw 90-degree line to this normal, you will be having tangent. So once again, your S point is on the curve P2 and P3, and we have generated this P2 P3 curve by taking 3 as a center, 3 P2 as a radius. So that means our center would be point 3. So you have to simply connect your point S with 3. You have to extend this line, it will give you normal, and line perpendicular to that will give you a tangent TT line. Very simple. So this is all from my side. If you have enjoyed my lecture, then do not forget to like and subscribe to show your love and support. Keep learning, stay connected. Bye-bye.